All right, this video is going to walk you through a quick overview of our chapter, starting with part over total. Part over total is just like it says. If you got 6 sides on the die, and you're going to say, what's the probability that you're going to roll a 6? Well, there's only one side that has a 6 on it, so it's the part 1 out of a total 6 sides, and the chance of you doing that is 1/6. Some other things to be aware of in your questions like these is just to be careful of the ones that say the word complement, and a little apostrophe, this little C here, and the word not heads. They all mean the exact same thing. The chances of you not getting heads on a coin would still be 1/2, but the chance of you not getting a 6 would be 5/6. It's the part that's left over. Experimental probability is talking about if you flip a coin and you get heads 9 out of 10 times, you got pretty lucky if you did that. But according to you, your experiment says that you got it 9 out of 10 times, so your experimental probability of getting heads is 9/10. But if you were to keep doing that coin, you will not stay that lucky. You'll get more toward what should happen, which is half the time you should be getting heads. So the more times you do something, the more it should go toward what should happen. So don't use this probability in this calculation when you do it a bunch of times. Therefore, it'll just be a half times 1,000 and get 500. All right, let's move on to independent versus dependent events. Independent events are when the first event does not affect the second event. Typical things you're going to see are like if you pull a card out of a deck of cards, and you put it back in, you're going to reset the problem. Whenever you reset the experiment back the way you started it, that's going to create independent events. Another thing you might have is where you're going to be pulling from separate sources like bag number 1 and bag number 2, and something comes out of each of those separately. Those would be independent events. Another typical one is flipping a coin and spinning a spinner. Those kind of things that are separate also, that's what makes them independent. The dependent ones, though, are where you take something out of something and you keep it and you don't put it back in, and then you try to do the exact same experiment again. Those create dependent events because whatever happened on the first will affect the second. Next, we're going to focus on just the independent ones alone. If you ask yourself, what are the chances of flipping a heads and rolling a 6? Well, you just take those two fractions, the chance of you getting heads and the chance of you rolling a 6, and you simply just multiply them together when you have an and statement. That's what you see here in blue. Next, if I were to ask an or question instead, the chance of you flipping a coin and getting heads or getting a 6 on a die after doing both those experiments, you want to take those chances first and add them, and then subtract off those same two fractions multiplied. If you enter that right in your calculator as you see it, you'll get the correct answer 7/12 every time. Now to get the actual fraction, you have to press math, enter, enter. And this is the general structure for the OR ones as well. You take the fractions of the two that you're working with, added, minus the same two things multiplied. And that's it. Hopefully that helps. Now let's move on to expected value. What you're going to notice about expected value is you're trying to find the value of a game. You see games all the time at value fairs, state fair, and so on. They ask you to play this game, but what is it really worth? The way you find out what a game is worth is you take the money that you could win. So if I were going to say, let's roll this die, and if you can roll a 1, I'll give you $2. If you can roll an even number on the die, I'll give you $10. How much money would that game be worth if you were to play it? Well, you take the money that you can win, first of all, multiply by the chance, plus anything else you can win, times the chance of it happening. So here's how we're going to set it up. If you could win $2, well, to roll a 1, that's a 1 out of 6 chance of happening, so I just take $2 times 1 out of 6. Then add that with rolling a 10, or rolling an even number, which has a 1/2 chance of happening, and that's times $10. Now if I add those together, this value and this value together, the total game is worth $5.33. Now that's what the average is. You're not going to win that amount every time. That's the average winning. So that means when the average person comes up to this game, you're going to be handing out $5.33 if you're the person running the game. So you might want to be making sure you charge more than that. Now, for the game to be fair, it has to be fair for both people. So only when you charge someone $5.33 to play this is when we call it a fair game. It can't be anything more or anything less than this to be considered a fair game. Hopefully that helps. All right, let's move on to counting now. With counting, we'll start in this lower section here first. When you're looking at a total number of items and you take something out of the group, sometimes even all of them, and you don't do anything with them, like group them, sets of, make a team, or make a cluster of, or assortment of, or committee of people, as soon as you grab those people or things and don't do anything with them, and that's all they are is just a group, then it's a combination calculation. But when you take these group of things and then you start doing something special with them, like arrange them, place them, order them, assign names to them, or do something special with them, then it's a permutation calculation. To do those actual calculations on your calculator, you'll have to watch that in a separate video. Then we talk about fundamental principle counting also, where individual decisions are being made, where you're going to make, like, let's say, a code or a password, or how many menu items you can make, or outfits you could make. Making a choice out of a group of separate choices from different groups is what these are all about. You first of all say, well, how many ways can I take a code, 10 characters, 0 through 9, that's 10 characters, to pick the first digit. And then I want to have a letter follow that code where I'm going to pick from 26 letters one thing. And as I start making my code out of letters and numbers, I multiply all those choices that I make together, and that's how many different possible ones you could make. That's fundamental principle accounting. Now let's move on to some examples. All right, let's try these examples here to see what we know. If you have 12 runners in a race, how many ways can they finish in first, second, and third place? Well, if there's 12 runners and you're going to take 3 of them, if it was just taking 3 of them, that would be a combination. But now that we are taking the 3 and putting them in a specific order, first, second, and third, now it becomes a permutation. And that's what it'll be. The calculation then will be 12p3. 12 is the total number of runners that you're working with, and the group size that you're picking is 3. And when you're placing them, it's a permutation. Next, if a teacher wants 4 of his 30 students to come to the front of the room, basically as a group, and you're not doing anything special with them, that's just a combination. So you do 30C4 on your calculator. But next question, if you have 12 people that want to get into a boat and that can only hold 5 people, as they get in the boat, there's no specific location for them to sit, so therefore they're just a group. That's what makes this a combination. So you just do 12C5. If you have a website that requires a password where you're going to make a decision, separate decisions for each of these different characters, for example, a capital letter, followed by 3 lowercase letters, and then followed by 4 numbers. Well, you have 26 letters that are capital to choose from, times 26 letters that are lowercase to choose from, and so on. And then you're getting down to the numbers. There's only characters 0 through 9, which gives you only 10 choices for the first numerical character here, followed by 3 more. And since there's no mention of the since it doesn't say you can't repeat them, then you can repeat them, and that's why we have a total of every time 26, 26, 26, and 10, 10, 10, 10, 10. But if it were to say you can't repeat the letters or the numbers, then you just start with the number total that you have to work with and start counting down from there. If it were numbers that can't repeat, you'd start at 10 and then go 9, 8, 7, and so on, and then multiply all those numbers together. If the photographer wants to arrange 5 people into a photo, again, if you see the word arrange 5 people, sometimes it might just say not even from a group. Well, it's 5 people from a group, and you're going to use all 5 of them. Then if you're arranging them, that's a permutation. So therefore, it's going to be 5p5. Next, if you want to build your own ice cream stand that offers 20 flavors, 12 toppings, and 4 sizes, and how many different orders can you pick? Well, you're going to see the word order, and you're going to think permutation, but you're making separate decisions. You're picking one of these, you're picking one of these, and you're picking one of these. And as you're doing those, that's a fundamental principle of counting. So you have 20 choices times 12 choices times 4 choices, and that is how you get 960. Hopefully these kind of ideas help in getting ready for our test. Good luck.